the white paper focuses on the Boeing 737 MAX 8 failures that happened a few years ago. I'm sure you can recall there was two flights that departed, and then very close to departure, they immediately crashed, going straight into the ground and killing or losing the soul of almost 346 people on board. And essentially, we investigate what exactly happened and how that happened in terms of the technical perspective, that how could the mistakes made in engineering lead to a flawed design, which could lead to catastrophic failures. Now, if you have more information on those crashes, the failures had to do with the MCAS system, maneuvering characteristic augmentation system. And most of the problems had to do with push from executives and managers to complete the project as fast as possible, which at many levels caused cutting corners, you could say, for lack of a better term. And those cutting corners were overlooked, which put into production a flawed system and led to the catastrophic failures. So in the paper, essentially, we just investigate those and then talk about how we can, as an industry, because there's always going to be timeline constraints and things and economic constraints, but with those, how can we avoid these mistakes? So the main things that went wrong were Boeing's intentional concealment of the use of MCAS. So they intentionally concealed the use of it to both the FAA and to their designated engineering representatives, which are engineers that work a part of Boeing, but are actually employed by the FAA to make sure everything that they're doing is checked off. The reason they did that was they knew that if they introduced a new system, which was drastically changing the control of the aircraft, that would require additional training, which would take more time. And they had this huge bet with airlines that, if you need any additional training for this aircraft, then we will pay you guys $1 million for each aircraft. So they had this huge bet as well to basically make this thing super seamless. And so due to that, they hit a bunch of details of what they were changing and how much they were changing it, and essentially skipped validation and testing of that, because any validation testing of that would raise red flags on, oh, what are you testing exactly? Why is this taking more time? And essentially skipping all those steps led to their disarray. The majority of the paper focuses on exactly this, on, with the time constraints and push from executives to move faster. And there's also Airbus had already released their direct competitor to 737 almost 2 years before this. So they were already 2 years behind. But the majority of the paper focuses on how exactly to move fast, but move safely. So this would be with the additional cover. Now, the reason that MCAS was such a problem is because MCAS was used on the Boeing KC-46A. So that plane also was quite large and was dealing with sort of the same aerodynamic problems that the 737 MAX 8 was dealing with. Now, that's where the problems begin. So MCAS then becomes legacy software because it's software that was used before. And it's also considered software of unknown pedigree, which is a term for anytime you're using any chunks or even whole libraries or any amount of software where you don't exactly know what the requirements or level of testing or what sort of procedures were followed, what the SOP for that software was when it was made. You consider that as soup. So what they did was they took that. So usually when there's a change to any legacy software, you should it has to go through DERs. They'll see, okay, well, this is the change. Is that valid? Does that make sense? And then normally there'll be a hazard assessment of it. So if we do this change, what does this affect? What other things could affect that are not even you might not be thinking about? So that was never done. And specifically thinking about cover. This would be this would not rely on humans, to put it simply, because any change that was made to the original system, you would immediately see that, oh, there's new lines of code here, or removal of lines of code here that don't have any test for them, right? So, for example, we can say that they got the software from KC-46A and it had like 90% coverage, we could say, for example. And then they put in these changes slowly, incrementally, and within a month or 2 months, the coverage drops to 60%, right? So, I mean, anybody can really see like, how did the coverage drop from 90 to 60% when supposedly everyone is saying that there's no changes to the software. It's the exact same as it was on KC46A. So that would be part of how cover would help to clearly show that there's a huge change in the software that nobody really overlooked or checked if it was safe or not. And then the second thing that cover will help with, sort of related to it, is that so now that there's a coverage drop, we should write more tests. And by writing more tests, you would be able to easily see that that this is not the sort of laws that they put, or the rules that they put for the system to follow, that when it activates, when it doesn't activate, how long it activates, sort of these things, those don't really make sense. They're not exactly safe. And in the white paper, I go into details on what exactly those were, on what they changed to, and the sort of apparent problem with those. If you just, I mean, any engineer can just look at them and be like, that's no, that's not a good idea. But testing would be sort of the non-human way. Say if nobody could really tell, like, oh, it sounds safe, maybe it does. But testing would be easy way to tell, like, okay, this is definitely not safe. So that would be the second part. So, I mean, essentially, number one is all the changes would be easily seen because of the drop in coverage. And second thing is that would require you to test it. If you have coverage, you can essentially see what requirements are being tested and what requirements are not being tested. So if there's some additional requirements added and that required a new code to be added, and there's no test for that, it's very easy to see that there's no test for these new requirements. As I mentioned earlier, a lot of articles mention that Boeing was under extreme economic pressures with Airbus and timeline pressures. They were already over budget, over time. I mean, everything you can possibly imagine. They were not in a very good position in terms of the project. But the funny thing is, like, these things are almost always existent in every project. Every project may not be over budget, but there's always time constraints. It's always running close to schedule. There's always going to be a competitor that's trying to beat you to market, and you're always fighting for the market share. So these things are always going to exist for all our clients, regardless of what industry they're in. That goes without saying. So then the question becomes, how can we move fast but safely? General guidance is that if you're going to move fast, then you have to increase testing. You need to incorporate something that is not going to require more engineering time, but that will cover your margin of error in a sense. It'll watch out for the extreme conditions that you might be overlooking. So in order to do that, everyone knows that testing is, of course, super important. But then the question becomes is, what are we not testing? What is already tested? So for that, cover can be helpful. So then the guidance that we could say is that if you want to move fast, incorporate cover, because it's going to help you identify where the code is changing. And that also tells you where your most valuable lines of code are. Or in a sense, if you have some system at some point A, and then you make changes to that system at point B, the areas that are getting the most changes are your most valuable because it's spending the most engineering time, right? Because everything else is staying the same. Nobody's really even looking at it. So there's no engineering time being spent on that. So cover can help you see what are my most valuable lines of code. And then it's going to help you make sure that are those lines being tested. And all of that comes together to make sure that is the system that we're developing safe, and you guys are already moving fast. That's based on your own timelines. But while moving fast, are we developing it in a safe manner? Because ultimately, no company really wants something like this to happen, obviously, because Boeing at one point was an engineering marvel, and in some regards still is today. They make amazing aircrafts and amazing innovation, but this definitely impacts their image.